This is the syllabus for the BSc Part 1, Paper 1. Which is called as a Mechanics 1. So anything which is moving comes under the mechanics, whether it is a vehicle moving from one place to another place, whether it is a planet revolving around the sun, or whether it is a electron revolving around the nucleus. So anything which is moving, okay, that comes under the mechanics. So in this mechanics, we are going to deal only with the two units. Unit 1 is vectors. Ordinary differential equations. Laws of motion. And in unit 2 we are going to deal with the momentum and energy and the rotational motion. So as I have already told you, anything which is moving, whether it is a particle moving from one place to another place, or whether it is a planet revolving around the sun, or whether it is a electron revolving around the nucleus, okay, so this everything comes under the mechanics. Okay, so before going to this mechanics, so there are few basic concepts which we must know. And what are they? These are the vectors. These are the ordinary differential equations. And then we have to study the laws of motion. Okay, actually mechanics starts from here, but before that you need to know about the vectors and you need to know about the ordinary differential equations. So in this part 1 of the unit 1, we are going to deal with the vectors. Okay, so there in a physics there are two physical quantities. Some are scalars and some are vectors. And we know that like temperature is there, mass is there, so these are the scalar quantities, whereas so displacement, r, velocity or acceleration, so these are the vector entities. Force is there. So as we are dealing with the mechanics, okay, so this mechanics deals with the displacement, it deals with the velocity, acceleration, force. Means 90% of the physical entities which are involved in the mechanics, these are the vector quantities. That's why the first unit is the vectors. So in these vectors we are going to study the basic definitions of the scalars and vectors. Then we are going to study how these vectors can be added, how those can be subtracted, how we can multiply them by using the scalar product and the vector product, and some properties of the scalars and vectors. Okay, so it is necessary to understand the vectors, how they are added or subtracted, and how they are multiplied by using the scalar product and the vector product. Okay, so this is covered in the unit 1 vectors. Okay, the second unit is the ordinary differential equation. So these vectors, once we have studied the vectors, so in a physics or in a mechanics, ordinary differential equation is nothing but it is a derivative of some variable with some n variable quantity. Okay, so a derivative is nothing but the rate of change of some quantity with some another quantity. So when we are taking the change of one variable with another variable, or change in physical quantity of one entity with respect to the another entity, so we call it as a ordinary differential equation. So the in a numerator it is a dependent variable with respect to the independent variable. So as we know that velocity is nothing but the rate of change of displacement with respect to time. Acceleration is a rate of change of velocity with respect to time. Okay, so these are the entities, so these are the dependent variables on the independent variable time. So these entities depend on this independent variable, and in a maths language it is represented by the differential equations. So these are nothing but the differential equations, and in physics or in a mechanics we need the relation between the dependent variable and independent variable, because these things are related with each other in this manner. Okay, that's why it is necessary to study the differential equations. So in that differential equations, so in that part 2 of the unit 1, we are going to deal with the what is the first order ordinary differential equation, then second order ordinary differential equation, then we are going to deal with the homogeneous and non-homogeneous differential equations of motion. Then third part is a laws of motion. So from here we are actually starting with the mechanics. We already know that Newton's laws of motion are the three Newton's laws of motion are we can say that these are the basic building blocks for the classical mechanics. From by the concepts of these Newton's laws of motion in nearly 16th century, from there onwards there started a classical mechanics. So these are the basic foundations of the classical mechanics. So we are going to study the three laws, Newton's three laws of the motion, on which all this mechanics is going on, and we are going to study those three laws of the motion in a part 3 of the unit 1. And then in unit 2 we are going to deal with the momentum and energy. As I always say, when you write the equation of the motion for the any particle, so what that equation of the motion tells about is that from that equation of the motion you can calculate everything which is necessary in the physics. Like you can calculate the displacement, velocity, acceleration, or momentum, or energy, anything you can calculate from that. So once you know this r, v, a and force from these laws of motion, the only the remaining things are the momentum and energy. Okay, so the momentum and energy could be calculated by using the conservation laws. So in this unit we are going to deal with the conservation laws of the momentum and energy. And finally, the second part of the unit 2 is the rotational motion. So the rotational motion covers almost 70 to 80% part of the mechanics. So as I already said, whether it is a motion of the planet around the sun, okay, this is Earth. So whether it is a motion of the planet around the sun, or whether it is a motion of the electron around the nucleus, so most of the forces we generally deal with are the rotational motion or the circular motion. They fall under the rotational or the circular motion. So the rotational motion covers uh, nearly most of the part of the mechanics. That's why it becomes necessary to study the rotational motion when we deal with the mechanics.